Sophomores, shop teacher chief here, late at night, shop has gotten quiet, able to sort of continue my late night talks. I'll pull my glasses up, I'll take my mask off. No one is here. Mr. Whitmire is out there welding, doing something quietly on the other side of the shop. And I want to continue my series about pieces of equipment in the sheet metal shop, fabrication techniques, layout, math, blueprints, you name it, we've been covering it all week. What I'd like to bring your attention to is the jump shear and the squaring shear. But before I drill down deep into this lesson, I would like to say how deeply proud I am of the sophomore class, how well you work together, how you apply your knowledge, how you have your know-how, and trying your best, and doing your best, and working with others, and helping one another. That is the most important thing. Each day you show up here at Assabet on the concrete floor, you try your best, you keep an open mind, you learn new things, new principles of welding and sheet metal and layout and fabrication, and that will pay dividends later in your life as you graduate and you have gainful, independent lifestyle, because you have a livable wage as a skilled man and woman here in the fabrication industry. So let me bring your attention to the squaring shear. The squaring shear is a piece of equipment, jump shear is terminology you'll see out in sheet metal shops. We have it here. It is an enormously important piece of equipment in the sheet metal shop. It allows you to be able to cut light gauge sheet metal rapidly in a shop. But you can go wrong. And the way you can go wrong with the squaring shear or jump shear is by taking round stock. A piece of round stock can destroy a piece of equipment. So rule number one, never, ever, ever, I'll say that again, never, ever, ever put round stock in a jump shear. Never put round stock in a power shear. Never put round stock in a Beverly shear. Never put round stock in a box and pan brake or an apron brake. It is a sure way of destroying the piece of equipment. Never take a piece of round stock and cut it with sheet metal snips, okay? It is inappropriate and it is reckless to do that. And I ask you never ever to do that. So I want to have that rule number one understood and very straightforward and clear. What I would like to talk to your attention about is the appropriate thickness of metal that is allowed to go into a jump shear to be cut. Number one, let me bring your attention down to the jump shear itself. Put my glasses on, put my gloves on. We've been working with sheet metal all week. Our Kevlar gloves, the most important, most critical piece of PPE that we have. So the first thing I want to talk about is the type of sheet metal that we've been using all week, which is 26 gauge. 26 gauge, we know we have a sheet metal gauge that it tells us what the gauge is by just putting it into the appropriate slot that fits evenly and precisely. And we know that this is 26 gauge. This gauge will tell you one side what the gauge is of the sheet metal. On the other side will tell you how many thousandths of an inch. So many times in sheet metal shops, especially precision sheet metal shops, you're working with material that is within a thousandths of an inch. So very handy tool to have in your toolbox. So there's a sheet metal gauge. So once again, if you could take your material and you can bend it flexible like this, it is appropriate to go into a jump shear or a squaring shear. So this is 26 gauge galvanized. The galvanized is a zinc coating that is on steel to prevent it from oxidizing and rusting. So we'll come back to that. Another particular material we have here, as we've been talking about, is a magnet test. This is a piece of copper. It's non-magnetic, non-ferrous, means no iron particles. We know that the material we've been working with is magnetic, iron particles, right? It's ferrous. Ferrous is the ancient Greek and Latin word for iron particles. We know that we have a piece of aluminum here. Aluminum is lighter, obviously, non-magnetic. Have a piece of black iron, they call that. It's this oxidation, a mill scale on there. It has iron particles in it, so it's ferrous. Come back again, light gauge. Ferrous has iron particles in it. Come back, looks like galvanized, but it's non-magnetic. It is stainless steel. Anytime you see a mill scale, which is an oxidation of material on there, most likely that's going to be iron particles, going to be ferrous material. Well, I've got a thicker piece of aluminum here. Non-ferrous, right? No iron particles. I'd like to bring your attention to how to measure sheet metal and the thickness. We know that we have a sheet metal gauge, which we use all the time, tells us the gauge and tells us on the backside the thousandths of an inch of it. But I wanted to introduce you to a new concept of what dial calipers are. And dial calipers are a measuring device that you would see in a machine shop application, in a precision sheet metal shop, and a regular sheet metal shop. So we know that we can look at the material, the 26 gauge. We know that we could use the dial calipers, and the dial calipers will tell us that that is 19 thousandths, 20 thousandths of an inch thick. Certainly appropriate for your jump shear. All day long, we can use that. We know we've got a piece of stainless steel here we talked about earlier. I come in with my dial calipers, I measure, and I've got 120 thousandths thick. Not appropriate at all for this machine. You will destroy that machine if you put that in there. We know we've got a piece of black iron. We don't know how thick it is. We know we've got, it's 62 thousandths of an inch, it's 16 gauge. It is not appropriate for this jump shear. We know that we've got a piece of aluminum, it's fairly thick. Come in, it's 180 thousandths, not appropriate for that machine. Have a piece of black iron, fairly heavy, fairly thick. Come in, measure that. It's 120 thousandths, not appropriate at all for this machine here. You will destroy it. We know that we've got a piece of copper, which is soft material, and that copper is 16-ounce copper, and that is 30 thousandths of an inch. It is appropriate to cut in this machine. Another piece of sheet metal here, 26 gauge, certainly appropriate. Got a piece of aluminum here, excuse me. Come in, measure with my dial calipers. That's 78 thousandths of an inch. Since it's soft material, it's okay to cut. So I have done a process of elimination of what is appropriate and what is not to go into the machine. Next, I'd like to bring your attention to how to use the machine itself. This particular machine is critical. If you look over here to the right and to the left, it allows you to put a sheet that is 36 inches wide in here. Many times jump shears and squaring shears have a back gauge. Our particular shear does not have it in the shop, but we do have a rule on each side. So if I need to go down and cut 6 1/4 inches, I come in at 6 1/4 on the rule. I use the hold down. I pull the hold down. I be careful of my feet down below. I put my leg up and I jump shear that. I measure and I have 6 1/4 inches precisely. I'd like to bring your attention to what they call a shadow cut. And now a shadow cut in fabrication shops and sheet metal shops is constantly being used. So if you have two different measurements, I'm going to come in, going to come up 4 inches. I always do a V to make sure I'm very accurate. I'm going to come down 2 inches. I'm going to connect my 2 lines. Now I've got a diagonal line coming onto a piece of metal. Just for instructional purposes here, I'll take a Sharpie so you can actually see what I'm trying to achieve here. So with that Sharpie mark, I'm going to do what they call a shadow cut. A shadow cut is when you're looking up where the 2 blades come together, and it creates a shadow. You pull your piece of material in there until you eliminate that line and that shadow, and that is your appropriate measurement to where you would want to jump shear your sheet metal. So here I am. I'm eliminating the shadow. I do my hold down, take my jump shear, and I jump shear that. And at that point, I've got my measurement, which is diagonal. So a jump shear has multiple processes that you can use: squaring, perpendicular, diagonal lines, shadow lines, okay? But I'd like to also bring your attention to, in sheet metal, we do a lot of radius lines. And with radius lines, I know it's the reflection of the sheet metal you really can't see. So I would use a set of wing dividers. And if I'm doing radius in sheet metal, which we do a lot of, use my wing dividers. And then at that point, so I'm not cutting with hand shears, I'm able to just do shadow cuts to speed up my process here. So just for instructional purposes, I have a radius line here. I'd like to bring your attention to shadow cuts again, just so that I'm not wasting so much time with a hand shear, a hand snip. I can come in several attempts with my shadow cut. I don't want to cut right on that line. Come in once again. And then I'm able to just trim that with my aviation snips, my lefts and rights, okay? So sophomores, bring your attention back again. Want to say, continue to do what you're doing. Continue to be the people that you are. Continue to learn something new each and every day. Continue to develop those skill sets that will enable you to be employable when you leave Assabet. And continue to get along with one another. Continue to help one another. Continue to develop a solid knowledge and baseline of sheet metal fabrication, because it will help you in your life when you become a sheet metal worker, a welder, a fabricator, whatever that field that you go into. The sheet metal layout and understanding blueprints and dimension lines, extension lines, all those complicated things that you see on the blueprint that look like a puzzle are now starting to get very clear and focused, and you have clear understanding of how to go about your projects. So sophomores, it's late at night, I need to get going, but I wanted to continue my talk in my series, the Chief Talks Late at Night. Fantastic class, absolutely adore you. Continue to do what you're doing, and we'll see you back here on the deck plate in the morning. Good night, sophomores.